All right, so we're going to be creating some plots for the Lab 4, which is the Spring Potential Lab. And to do this, we first have to take our data for our amount of our spring length. So we measured some length, some x, in meters. And we have a force, which is going to be in newtons for each of those. Right? So we make these a little bigger so they're easier to see. I'll bring this up to about 18. So let's say that my initial length when I first stretched it, it went up to a 0.14, then I went a 0.16, then a 0.18, then a 0.20, and then maybe like a 0.22, okay? And from this, I got forces of 0.39, maybe a 1.67, and then like a 2.95, then up to like a 4.23, and then finally like a 5.51, okay? So obviously your numbers will be different. You know, you might have 5 points like I do, you might have 10 points, just depending on which version of the lab you did. So we'd highlight that, and then we would go and create a chart. So if you either go down up top here and go insert a chart, or you could find the chart button that can just looks just like that over here for insert chart. So we're going to insert a chart, and the type of chart is going to be a scatter plot. So we scroll over and we find scatter plot, and it kind of looks like a nice little straight line thing going on here. So now we have to customize it. So chart style is fine. We get to chart titles and axes. Well, the title we might want to be a little more descriptive. So for this first one, say this was a purple spring. And we knew the accepted value was, say, 65 newtons per meter, you know, measured on a box or something. And it was plus or minus, well, 10% of that, which would have come out in our case to be 6.5 newtons per meter, okay? And then we can state that, you know, our other axes here will state what we had in the horizontal, what we had in the vertical. Well, on the horizontal axis, we have the spring length, and that's going to be in meters, okay? And then on the vertical, we will have the force applied, and that's going to be in newtons, okay? So now I've got my two axes labeled. Nice little descriptor there. And just like before, chart subtitle, still going to be our name, so in my case, mine will be Mr. Magno. Again, just so we know who actually made the chart. So we get down to series here, and we're going to be putting on trend lines and possibly error bars. So first, I'm going to change my point size down to 0.2, because I just want my points very small. So for the force, the error was most likely a 0.1 fixed value, so constant, not 0.1, 0.01 fixed value. So we might not actually see, you know, the error bars, the little lines are there. I don't need to see my data labels on it. I could if I wanted. And then the trend line, that's the important thing. Our trend line in this case should hopefully be linear. We can verify that by looking at the R value. And I look, my R value is very close to 1. Yours might be like 0.999 or so. And I'm going to say use equation. So I want to use my equation, and it shows my equation right there. So here it looks like I've got 64 plus or minus, plus a negative 8.57 offset. Okay. So we're going to use that for our nice, you know, linear fit for the equation. The legend, I generally like to put my legend at the bottom. Horizontal axis, I do generally like to make sure that we start at a minimum of 0, and maybe just in this case we'll go up to 0.025. Okay. Oop, 0.25, not 0.25. Just so we get an idea of what the actual slope looks like relative to 0 to 0.25. Otherwise, that slope would look kind of just shallow because it tries to fill the screen. So that gives us a good view of what it looks like. Don't have to change anything with the vertical axis because it'll automatically scale that. And we're pretty much done. Now, the big key thing here is we need to figure out from this graph what is the actual observed k value. So if I look down here, I see this function, and it's 64 times x. So that normally we talk about the force of the spring as like negative kx. So our force applied is kx. Okay. So in this case, 64 newtons per meter is our observed k value. Okay. We need this value. We're going to take this with us to create our next kind of plot. All right. So remember, we got 64. You'll obviously get a different one for each of the different color springs you did. All right, so you'll be repeating this process for each color spring. So you had a red, a blue, and a green. Well, so let me label this down here. So if you notice down here, I got sheet. So if you notice, I'm right down here right now. Oops. Just erase that. I'm going to actually change that little sheet piece here and call that my F versus X purple, just so I can keep track of these. And over here, you'll notice there's a little plus sign. So I'm going to add a, label it now. This is going to be my PE versus X for purple. All right, and this will just help you keep track of your different sheets. All right, so I'm going to make these a little bigger so you can see them as we go. So now, before, my X that I was looking at, okay, in meters, was the actual total length. Well, this time I'm going to look at what was the change. Well, I was stretching it by 0.2, 0.4, okay, 0.6, 0.8, okay, and then finally a 0.10. This is how much I actually stretched it. But now I need to figure out the PE for the spring, and this is going to be in joules. Well, for this I'm going to have to calculate it, and if we remember, our equation for PE spring is equal to 1/2 kx squared. So I'm going to type this in as 0.5 times our k value. Well, our k value right now is 64. This will change for each one of the springs, times our x value. Well, our x values right now are in A, so I'm going to start with A2 caret 2 in that first box. All right, I'm going to put an equal sign. All right, so let me type that in right here. So I'm typing in equals 0.5 times 64 times A2, if you notice the A2 box highlights, caret 2. All right, enter. So that just calculated the energy from that value. So now if I grab the little box here and I pull down, it'll grab each one of the x values, square it, and calculate the potential energy. All right, it's just going to keep following that same function that I just wrote there, but for each of the energies. So now, just kind of erase that, and we are going to make our plot of this. So I highlight both columns, insert chart. All right, it defaults to a line right off the bat. It's not what we want. Again, we want a scatter plot. So we've got our scatter plot here kind of hooking upward. Customize it. So now this chart will have a chart title of probably something to the thing, Purple Spring. And we'll call this the potential energy plot. Okay. And then you might want to say the observed K equals 64 newtons per meter. Okay. Just so we know that we're using a certain observed value to make that plot. So chart subtitle again is our name, so in this case it's Mr. Magno. Horizontal axis is our displacement this time, okay, which will be in meters. And our vertical will be our potential energy, which will be in joules. Okay. So we go to our series. Really don't need error bars, data labels, but trend lines. If you notice right off the bat, it's not linear. Okay. I'm also going to make the dots a little smaller, make those down to 2. It's actually going to be polynomial, all right, and it's a polynomial order 2, which kind of makes sense because we have an x squared relationship. And if I, again, just want to verify that, I check the r squared. R squared looks good. I think the r squared showed up as 1. So customize, I'm going to use the equation. And if you look at the equation, it basically shows I'm plotting 32x squared. Half of 64 is 32x squared. So I've now got that pretty much done, other than I need to move my legend to the bottom. So I'll move my legend to the bottom. Okay, and there we go. Legend's now at the bottom. So hopefully this kind of answers your questions on how to make these 2 plots. Again, you'll be creating one for each of the 3 colors that you have. So one for red, one for green, one for blue.